Welcome back, guys. Today we'll be talking about calculus and functions. So this is for ordinary level. We'll be looking at the 2019 paper 1 question 3. Let's get started. So this is question 3. It reads, the function f is defined as f of x is equal to minus x cubed plus 4x squared plus x minus 2. And then part A is saying complete the table below for the values of f in the domain 1 to 4, and hence draw the graph of the function f of x in that domain. So the first step is to fill in that table. So we're given x values. So we're given x values here. We're given x is minus 1, 0, 1, and so on. And then they want you to fill in the values for f of x. So what's the value of the function when x is this value? So f of x is also the same as y. So most people are familiar with given an equation that says y equals instead of f of x. So these are interchangeable and they're the same. So they could have said y equals something here and or f of x. So f of x just means a function of x. It means a function with x's in it. So they could have given this as another letter q or y. They usually use y, but it means the same. So I'll just put the y here. So you have to fill that in. So basically what you do is you sub in the values, these values, the given values for x into the equation, and you find what the value of f of x or y would be. So you put in minus 1 here for every x in your calculator, you get the answer. You change that value to 0, to 1, and so on until you fill in the table. So this one has already been done for us. So we do the rest of them. So the first one, we substitute minus 1. So minus 1 here, we substitute it into every x value here. So we don't change anything else in the equation. We only substitute minus 1 for x. So all the other things, the other the pluses and the minus, they remain the same. So if you do that, you're gonna have minus. So we have minus bracket. So use brackets every time when you're inputting the x. So this makes it easier to change things in your calculator. You don't have to type the numbers all over again. You just have to change the numbers you put in brackets. So these are representing the x value you're putting in. So we have minus bracket for x. This time we're putting minus 1. So minus 1 cubed, and then plus 4. So it's 4x squared. So 4 minus 1 squared plus x, which is minus 1. Minus 2. When you put that whole thing in the calculator, you get 2. So f of x is 2. You do the same when x is 0. You get a number and a value of x. F of x equals minus 2. You sub in x equals 1. So you do the same, and then you get a value of 2. And then you do the same again for x equals 2. You get a value of 8. You continue. You skip the 3 because it's already done. They already found 10 for that, so we do 4. We sub in 4 for x. So we're doing the same thing. We put in 4 every time when there's an x, and then we put the whole thing in the calculator. We get an answer of 2. So we completed the table, and then the next part was saying draw the graph of the function. Okay. So to draw they have given us the space to draw the graph here. So you have the x-axis and you have the y-axis. So we have the table that we completed, and you have to draw the graph. So when you're drawing the graph, you're mapping the x values and the y values. So this is important to know that f of x is the same as y. So this is x, y values. So you're mapping the x value and the y values. So we start with the first one, minus 1 in the x and 2 in y. So we're gonna go in minus 1x, so it's here. And then 2 in y, it's here. So we're going to have a point there. And then the next point is 0 in x, and then minus 2 in y. So we're going to go 0 in x, and then minus 2 in y direction. So this is the y direction, the x direction. So 0 in the x direction, we don't move from here, from the origin. And then minus 2 in the y. So here, put a point there. And then the next point is 1, 2. So it's there. The next point is 2, 8. It's there. The next point is 310. It's there. And then the last point is 4, 2. It's there. So now the final step is to join them up. So it's important to remember that the equation of this had an x cubed in it. So that gives us a hint of the shape of the curve. So it's kind of curvy rather than straight lines. So that is important. So you have to know the shapes of the different ones. So if the highest power of x was 1, so the equation looked like x plus 3 or something like that, it will be a line, a straight line. And then if the equation had an x squared term in it as the highest power of x, it will look like a quadratic, so it will look u-shaped or n-shaped. And then if it's cubic, it will look like a wave, so like a sine wave. So it's important to know that the general shape. But anyway, you can join the points as such. So you join the points, and then you get this kind of like a sine wave or cosine wave shape, a wavy shape. This is all you get a shape like this always when you have an x cubed term as the highest power of x in your equation. So there we go, we drew the curve. So make sure that these are not joined by straight lines, so you can use your free hand like this. This is perfectly fine. So don't use a ruler to plot them out, because that would represent linear kind of curves. So you can just use it's okay to use your hand like this, because it's a cubic equation anyway, so it's meant to be curvy, not straight. It's not meant to have pointy points, so it's meant to be curvy like that. Anyway, so we drew that, and then now the next part of the question was saying use your graph to estimate the true roots of f of x for which are in the domain -1 to 4. So this just means that the domain is the space in the x direction. So they're saying in the x direction -1 to 4. So obviously this curve might have started all the way here and ended all the way maybe down here, or it may have risen again or something. They're just saying here, don't mind what happens after or before this range, so it's called domain. Anyway, so they're saying use the graph to estimate the true roots of f of x in that range. So roots are points where the curve or the graph intersects the x-axis. So they are points where the graph cuts the x-axis. So in this case, we see that this graph, we follow it from here, it cuts the x-axis here. So this is the x-axis, it cuts it there, and then the graph is going again, and then here it cuts the x-axis here as well. So they're saying find the roots, so find those points where it cuts the x-axis. So here, if I'm to estimate, so you have that one and this one. So if I'm to estimate here, like what that point is here, it's between 0 and 1. So an estimation, again, it's anything that is reasonable. So it's not, doesn't have to be accurate, we're estimating. So we know that our estimate should be between 0 and 1, and it's a little bit, it's over 0.5. So this obviously depends with how artistic are you, how good a drawer are you, but anyway, you should generally get something like this. So this is between 0 and 1, so it's a little bit over 0.5. It's about here, halfway. It's a bit over 0.5. So I would guess maybe this is 0.7. So even if you say 0.8 or 0.6 or 0.9, it's still acceptable because it's an estimation. So I guess 0.7. And then the other root here, it's pretty much the same, but it's on the opposite direction. So it's between 0 and -1. So we're going here -1. So this is I would say this is -0.7, and then you estimate that. Again, it's an estimate, so you could have 0.6 or 0.8 or whatever. That's still acceptable because it's still within reason. It's still within reason from what you can see here. But then, for example, if you said 2 or something like that, it would be wrong there because it's far off from where it should be. Because when you have these 2 points, you have to connect them. So that connection here is meant to be between 0 and 1. There's no way you would have a line going through here to connect, trying to connect here. So Yeah, I mean, anything after 0.5 and before 1 is acceptable, depending on your drawing. The next part of the question was find the value of x for which f double dash of x is equal to 0, where f double dash of x is the second derivative of f of x. So this is calculus, this is differentiation. So they're saying find the value of x for which the second derivative, so second derivative means that you differentiate the function once, the answer you get, you differentiate it again. So second derivative. So you do differentiation twice. So they're saying when you do that, when you differentiate your function twice, solve that function, so find the value of x for which that function is equal to 0. So you get the function, you get f double dash, and then you let it equal to 0, and you find x. So let's do that. Let's get f double dash first. So this is the function that we have at the start. So f of x, this is f of x, what we have at the start. So we're trying to get from f of x to f dash, and then to f double dash. So we have f of x, we differentiate it once, we get f dash, we differentiate it again, we get f double dash. So that's what we're trying to do. So we have this function fx that we're given at the start of the question in part A. So we just write it more exploded like this so that I can kind of show what's happening in each term. So we have the when you're doing differentiation, you do each term individually. So you differentiate this term, you differentiate that term, and differentiate that term, and then differentiate that term. You put them all together, and that's your answer. So let's do that. Let's start with this term. So that one, when you differentiate it, first the steps is you write the constant. So you write whatever value it had here before. So in this case, it will be -1. And then for this one, it will be 4, for that one, it will be 1 here, and then for this one, it will be -2. So you write the constant, so the number that you have in front of here. So in this case, the number would be, so we are constructing f dash now. So we are differentiating this function. So we get f dash. So when you differentiate x cubed, you write the number that was in front of it before. So it's -1, that was there before. And then you write the power that was there before, which is 3 in this case, and then you write x to the power of whatever power that was -1. So this was 3 minus 1 is 2. So this is like the steps involved. Obviously you can do this much quicker, you can do this quite fast, but this is just assuming that maybe you need a refresher on differentiation or you haven't done it before. This is kind of like the standard procedure of what you do. You write down the number that was there before. In this case, it's -1. You multiply it by the power of x, the current power, which is 3, and then you write x to the power of what it was -1. So you take down 1 power, you go down 1 power. So it's now 2. So when you boil this down to just remove the brackets, so you're gonna have 3 by -1 is 3, so you're gonna have 3x squared. 3x squared. So this one turns to 3x squared. So if you're familiar with differentiation, then you skip the step, you go through this one real quick. But this is just what you're doing in your head anyway. So we go to the next one. So we do the same. So we do the same to all of them. We write the first number that was there before, so it's 4, and then you write the previous power. So the previous power is 2. So you write 2, and then you write x. The new power of x is now what it was before, which is 2 minus 1. So you're going to have 2 minus 1 is 1. So you have the power of x went down by 1. It's now to the power of 1. And then you boil that down. 4 times 2 is 8. So x to the power of 1 is x. So you have 8x. So this one boils down to 8x. And then we go to the next one. It's x. So again, follow the same procedure. We write down the number that was in front of it before. So it's 1. And then the power of x, so here this is x to the power of 1, you write 1, and then you write x to the power of what it was, -1, so it was 1, so now it's x to the power of 1 minus 1, which is 0, and we know that anything to the power of 0 is 1, so you're going to end up with 1 times 1 times 1, so this is 1, so that will turn into 1, and then this one, anything that doesn't have and x, when it's differentiated, turns into 0. So this just goes to 0. So when we have that, now we have f dash. Remember, we're trying to get f double dash. So we do this again. So we do the same procedure, but now we're doing it on this, on f dash, to get f double dash. So we do the same procedure. That one turns into minus 3 by 2 by x, and then that will turn into 6x minus 6x. 8x will turn into 8, and then 1, remember it doesn't have an x, it turns into 0. So now we have f double dash is minus 6x plus 8. So we have f double dash, so what do we do now? They're saying find the value of x, so we're looking for x for which f double dash is 0. So they want you to find x in this equation here, not in the original one, not in this. They don't want you to find x in this. It will be a different answer. They don't want you to find x in this as well, because that will be different. That's f dash. They want you to find x in this equation, the equation of f double dash. So this is a totally different, as you can see, it's a totally different equation from this one or this one. So if you solve for this one, you get a totally different answer. So you're looking for x, so find x in this function here that we found, and then we let it equal to 0. So we're gonna get this function, we have it, we let it equal to 0, we solve for x. So we have f double dash there, we let it equal to 0, so f double dash, which is minus 6x plus 8, we found that, we let it equal to 0, and then try to find x. So we have f double dash, which is this, minus 6 plus 8, let it equal to 0, we're solving for x. So we're solving for x, we move the 8 across, it becomes minus 8, we have minus 6x equals minus 8, or rather, we take away 8 from both sides, so it's the same thing, whichever way you were taught. So it's either you take away 8 on both sides, or you move, so this is easier to visualize, you move the 8 across, it becomes minus 8, so we moved it across, and then now we divide both sides by minus 6 to get rid of minus 6, so that we end up with x equals minus 8 over minus 6, which is 4 over 3. So thank you very much, guys. Please subscribe for more videos and share with your friends that can also benefit from this. Thank you.